Welcome to today's YouTube tutorial on debugging code on the Korvo-2 development board using the Espressif IDE on Windows OS. In this video, we'll walk through the steps to set up the necessary development environment provided by Espressif. Let's get started. First, we need to install ESP-IDF, ESP-ADF, and Espressif IDE to set up our development environment for the Korvo-2 development board. Before proceeding, it's crucial to verify the compatibility between ESP-IDF and ESP-ADF. This step is highly important as using incompatible versions can lead to numerous issues. To check the compatibility, we'll refer to the GitHub repository of ESP-ADF. Verifying compatibility ensures that the components work harmoniously. At the time of creating this video, the latest ESP-ADF master branch is compatible with the ESP-IDF release version 5. However, for our purposes, we will be using the ESP-ADF master branch with the ESP-IDF release version 4.4. Now, let's proceed to download ESP-IDF version 4.4 and the latest Espressif IDE using the Universal Installer. You can obtain the Universal Installer by visiting this link. By utilizing the Universal Installer, we can conveniently install both ESP-ADF version 4.4 and the latest Espressif IDE, which is currently at version 9.0. Now let's proceed with running the installer. After downloading the installer, we will go through a few steps to select the required version of ESP-IDF. As agreed, we will choose release version 4.4 for ESP-IDF. I will now install the necessary ESP products into the default bus. The installer will not only download the latest Espressif IDE, which should be version 9.0, but also install all the required Windows drivers and necessary files for the selected target. In our case, we are specifically looking for the ESP32S3 series, which is already checked for by the installer. Let's proceed and complete the installation. Now that the installation is complete, we have a dedicated folder that contains the framework and the necessary tools that we will utilize throughout our development process. Additionally, the installer has also provided us with certain shortcuts that grant command line access. These shortcuts will be useful if we need to perform debugging, downloading, or use the command line interface. However, for the purpose of this tutorial, we will primarily be using the Espressif IDE. Once the installation is complete, we need to download the full ESP-ADF repository from GitHub. Open your terminal or command prompt and run the following command. This command will clone the default master branch for ESP-ADF repository, including all its submodules, to your local machine. This repository contains all the necessary libraries and examples for developing audio applications with ESP-ADF. I'm going to download the ESP-ADF in the same Espressif folder where the ESP-IDF and Espressif IDE is installed. Step 2. Modifying the Korvo-2 development board. Unfortunately, by default, the Korvo-2 development board comes with the JTAG interface disabled. Instead, the board uses an external USB serial chip CP2102N to interface with the S3 on UART 0. This allows for code downloading and monitoring diagnostic messages, but it does not support JTAG debugging. If we check the board in the Windows Device Manager, we will see only one UART bridge listed. Additionally, if we try to run OpenOCD, we won't be able to establish a JTAG connection. However, the board can be modified to switch to the internal USB interface, which can be used for downloading, monitoring diagnostic messages, and debugging by moving a couple of resistors. Let's take a look at the board schematic to understand the modification process. Currently, the 0 ohm jumper resistors R181 and R182 are installed instead of R394 and R395. We need to move these resistors to the R394 and R395 positions. This change will allow J6, the USB port, to connect to the USB serial JTAG controller through IO19 and IO20 of the ESP32S3 Room 01 module. These pins, GPIO19 and GPIO20 on the ESP32S3, are used by USB_D and USB_D+ to provide two USB channels, one for JTAG and the other for the USB terminal connection to monitor diagnostic messages. Now let's open the device manager and observe the changes. After moving the resistors and powering up the board, we should see one serial port over USB and one USB port for JTAG in the device manager. Now, let's try running OpenOCD once again to establish the JTAG connection and proceed with debugging. Now we are ready to debug our first project on the Korvo-2 development board. Step 3. Debugging Korvo-2 using Espressif IDE. Now, let's begin the process of debugging by working with the first example project from the local repository of ESP-ADF. We will specifically choose the LCD camera example for this demonstration. To keep the repository organized, let's make a copy of the example project in a separate test folder. Open the Espressif IDE and select a new workspace, ensuring that the workspace name and path do not contain any spaces. We will use the import wizard to bring in the LCD camera example. Select Import Projects for existing IDF project and specify the location of the example project. Before proceeding, let's change the target to ESP32S3 in the project settings to ensure compatibility. To confirm that there are no compilation errors, we will build the project. If the compilation is successful, the sdkconfig file will be generated. Open this file to modify an essential configuration, the audio HAL. Select ESP32S3 Korvo-2 v3 as the desired configuration. To enable debugging, we need to create a new configuration using the ESP-ADF GDB OpenOCD debugging option. Choose the appropriate debugger for the Korvo-2, which is the ESP32S3 chip, via the built-in USB JTAG connection. With everything set up, let's initiate the debugging process by clicking the Debug button in the Espressif IDE. At this stage, the Espressif IDE will download the generated binary files to the board and trigger the debugger. While it's optional, it is recommended to switch to the debug perspective for a better debugging experience. The Espressif IDE will remember your chosen perspective for future sessions. The debugger will halt at the app_main function, and the board is now ready for various debugging activities. These include conditional breakpoints, step into the COD-watch expressions, modifying variable values, using the expression view to evaluate expressions at runtime, and even check the stack trace when the debugger is paused. That wraps up our tutorial on debugging code on the Korvo-2 board using the Espressif IDE. We've covered the essential steps to set up the environment, configure the project, and modifying the board to allow debugging. I hope you found this tutorial helpful. Don't forget to like, comment, and subscribe for more tutorials.